It is now stated in the national curriculum that a high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. So what is computational thinking? Barr and Stevenson believe that computational thinking is finding solutions to a problem that can be applied with a computer. But what would the teaching of computational thinking involve? Brennan and Resnick say that there is little agreement about what computational thinking encompasses, but within the context of the national curriculum it involves algorithms, debugging, decomposition, and abstraction. To some, it may initially seem absurd to use these terms in Key Stage 1, so what do they really mean? An algorithm is an unambiguous procedure or precise step-by-step guide to solve a problem or achieve a particular objective. With this simple definition, it is clear to see that in many ways children already use algorithms in other areas of the curriculum. For example, in science they may create a set of precise instructions to follow, or in maths they follow a set of steps to work out a calculation. If this is explained, the words do not become something to fear. Debugging would be discovering that the program has broken and fixing it. Sennett believes that to make and repair the object must be taken apart, fixed, and then restored. Through doing this with a program, children will be able to see where they went wrong, why, and how they can fix it so it returns to its original state. As decomposition suggests, it is the reducing of a large problem into smaller problems which, within a computing context, may mean deciding what you want your program to do and handling each criteria one at a time. Abstraction is defined by Barr and Stevenson as simplifying from the concrete to the general as solutions are developed. Therefore, children are learning how to adapt and work with something that is not tangible, which they may not be used to. I would argue that all of these skills are interrelated. To debug a program, a child would need to decompose it first. Through decomposing, they are learning how they can create algorithms to use within the program itself. How can computational thinking be taught? It seems that for many teachers, teaching computational thinking can be daunting to imagine. Vaughan says that there are only 400 teachers expecting to train 22,000 primary schools, but Berry believes that although the curriculum may not be perfect, it is not beyond our capability. I agree, as technology is such a large part of children's lives, it would be naive to think that they do not have such capability. I have seen on placement simple activities such as children writing instructions for a partner to draw a face that have been a missed opportunity to teach computational thinking. Children would learn through this activity how important it is to give precise instructions because they cannot speak to a computer in the same way that they can a person. In asking them to explain how to draw a face to a partner, they will also be decomposing, breaking down a large problem, i.e. the face, into smaller problems, i.e. the features. When reviewing the activity, the face will not turn out how the partner expected, so they can debug their instructions and amend them for next time, finding out where they went wrong. The strategies and skills they will have learned in a concrete way can then be transferred to a computer-specific environment. These can be transferred by giving opportunities to program using Scratch. This is particularly useful as although it is on a computer, children can still see the instructions they have given and alter them if they need to.